The next topic that we're going to be discussing here at the Networking Field Day Delegate Roundtable has to do with some of the exciting advances that we've seen in the networking space over the course of the last, oh man, what are we on now, like 8 years or something like that? Now, you've probably heard all about automation, and if you've been keeping up with it, you know that it is in fact not coming to take your job, as we have been led to believe. It is actually enabling us to do a lot of really cool stuff. But one of the things we've learned about over the years is that automation is only as good as the data that we're feeding it. And we have to get much better at getting that data, which is why we've seen a huge rise in the number of companies that are providing visibility into our network. You know, it turns out that the data's been there all along, we just didn't know how to see it. And so companies that we've talked to here at Networking Field Day, both at this event and many other ones, are trying to pioneer ways to identify the data that we want to see and then do something with it. So on the one side, we've got automation companies that need a whole lot of data in order to get something accomplished. On the other side, we got visibility companies that have a whole lot of data and they need to do something with it. It feels like these two things should be interconnected somehow, but yet they're not. And so we need someone like, I don't know, Reese to put together a chocolate peanut butter cup and get some chocolate in my peanut butter and vice versa to make this whole thing work. So I guess the premise for this roundtable is that the automation and visibility companies that are out there really should be talking to each other a lot more closely. I mean, has anybody in here ever tried to implement an automation scheme without feeding any kind of data into it? How did that work out for you, and why you have gray hair or no hair right now?
Hey.
To be fair, your hair turned gray a long time before you heard about network automation. But to me, that's one of the challenges. Is automation is like it's like an idling sports car. Until you give it the gas, it's not going to do anything. It has a lot of power, but it needs a little bit of direction to make it happen.
Yeah, that's true. I think with the automation, there's really these two buckets, and it's the second one I think that gets the most out of this observability. There's the things you're automating because you're creating new things and you're deploying new services and the like, and that really only needs the visibility to confirm that things are okay to proceed and to confirm that the stuff you didn't do any damage and actually did what you thought it did.
Yes, it's the way that I tell my kids to clean their room. I'm going to give you directions, and then I'm going to go make sure that you did it right.
Yeah, but I think the real opportunity in this space is these observability, and monitoring companies have the ability to see that something's happened, and therefore send a request to an automation system to do something about whatever has happened, and correct that issue. And that's where I think the really big opportunity is for these folks to work together.
Yeah, I'm glad you said that. Sorry, go ahead.
No, I was just going to say, yeah, remediation of an outage or a failed piece of equipment or whatever. That's where I see the observability talking to the orchestration that has a real impact in the future.
All right, I'm going to be Debbie Downer then, and I'm going to say, do any of y'all truly trust any of these systems to make the right decision?
Absolutely
not make
not.
Things work? Okay, then let's go home. We're done.
Well,
wrap it up.
I have already done this manually out of Splunk notices from things. When you have enough tickets that come in that you write a Confluence article on how to deal with this ticket and follow these steps, have NOC technicians that see the alert come in, it shows up on the dashboard, they run these steps, then you write the script that does it, and then you tie it to the Splunk alert coming in and running the script, and then the NOC just confirms everything that's actually happened and does this. Well, yes, this can be done, but that was a freaking 4-month process and positively painful to create. I wanted someone to help make this faster.
Well, hold on. Let's rewind. Let's rewind just a little bit. So, John, or Debbie, as you're now Debbie Downer, why don't you trust the system? Like, what is it about the system that makes you have pause? Because I'm standing in
Because we were involved in building it.
Fair enough. I'm standing as
Let me ask you the related question, right? Which is, why do most people run an IDS and not an IPS?
because
Right,
they don't.
It's wrong.
Right. If it's wrong, you break production traffic and you've just made a worse problem than the security risk you could have identified and tried to deal with in the first place. And that's the problem, is how do you guarantee that what you do doesn't make the wrong decisions or make the problem worse? So to the point made earlier, absolutely, you can find use cases where you can script that out, make a run book, and then perhaps automate that run book.
So
But
John, hold on.
you know,
My question, and I know Tyler wants to get in here, but just going to ask. So you don't trust a computer program to make the right decision 100% of the time, but you trust the interns to do it. What's the difference between an Ansible playbook and Billy, the kid from college who's learning how to implement this stuff?
And there's your first level knock.
The kid from college fears it.
it's not even necessarily trusting the intern to do it. It's trusting somebody to make the decision to not do something, right? This is sometimes the power of the decision is to make the decision not to do something.
I can build those decisions into a script. If this, then this, else that. So what you're saying is that there are a lot of factors that go into making these decisions that we need to make sure that we account for when we're building a platform to do them.
Tom, you're very good at this. Have you considered doing any kind of social media, podcasting and stuff?
Not anymore.
Okay.
Do you trust ChatGPT? I mean, GPT. I mean that.
No,
that's
because
the
it's
same
going to put
question,
me out of a
right?
job.
Right.
No,
No, it's not.
Chat GPT is another.
I thought we
Yeah, that's a whole other podcast.
Yeah.
I could talk forever on.
So I think the real question to ask is why are we afraid of something making changes? And the reality is that we're averse to risk. Something goes wrong, something goes bang, and the house of cards falls apart, and we're all in a terrible space. And why are we in that state? Because we bought a single switch with a single uplink, and if the script shuts that uplink down, we're all hosed. Right? Like, obviously, nobody does that, right? Like, nobody's ever bought a single switch with a single uplink for a critical host.
And a single power supply.
Yeah, there you go.
That never happens.
So I'm actually, hold on. I'm going to jump on John's Debbie Downer wagon here for just a minute, because we are not risk averse as an organization, unless you're in security, in which case you are the most risk averse person that I've ever met. You are actually blame averse.
Yes.
You don't want things to not happen. You want to have someone to yell at when the wrong thing happens, because if you install an XDR solution, I'm going to pick on XDR because it's something I've done a little research on recently, and 99 times out of 100, it stops an attack before it can progress into being a huge incident, or it shuts down a VPN connection that shouldn't have connected into your network, you honestly do not care. The one time that it blocks the CEO of the company from being able to look up this thing, the CEO wants to yell at someone because it went wrong. And we want to be able to pass the blame along. Does everybody remember, by now it's probably it's a legendary story of a SolarWinds. It wasn't SolarWinds, it was a guy who was using SolarWinds to upgrade switches all over like the country or whatever. It's apocryphal at this point, but the point is like he downloaded a bin file for the switch, and he had the automation run it once to make sure that it worked right, but something didn't work properly. So he forced the bin file to be installed in NVRAM on the switch. And then before he could verify the switch came back, he had it do 500 of them. And it turns out that the reason why the automation broke the first time is because it wasn't installing the right bin file. And when he forced it to do it, he bricked all 500 of the switches. And I believe the top Reddit comment was, I hope you can use the automation to write your resume. Because in that case, the automation did exactly what it was supposed to do. If it didn't do the right thing, it broke. And this person was like, I know better than computers. I'm going to make it do the thing I think it should. And at that point, there was nobody to blame but him. So are we finding ourselves in a situation where it's not that I don't trust the automation to do its job, no matter how much data I feed it? I just want to point fingers when it doesn't do the right thing.
Can I kind of interrupt here? That's
Go
a
for it.
great point. So in aerospace, I won't get into it too much in depth, but we are extremely risk averse in that
Yes.
if our rocket fails, it blows up, and we don't want it to hurt people, right?
hmm
So we're designing everything to be as safe as possible. But I will say that everything on a rocket, for the most part, it has to be automated at a certain point because you can't be up there on the rocket with it. And at a certain point, you get up into the atmosphere and out into space. It's hard to you can't get like instantaneous knowledge of what's going on the network anymore, right? So I think it's interesting because we have such strict requirements. Our stuff failing could potentially result in a loss of human life. So we're extremely careful with it, but we do technically have a completely automated network. And so to me, it makes me think that like we actually just don't necessarily have a lot of confidence in either ourselves, our hardware, the software, something.
So
Right.
Lexi, I will actually bring up a good point because you actually hit on something that we saw at Field Day. I want to say back in 2012, anybody in here who knows who David Meyer is? He was the first person to ever give us a machine learning presentation. John was in the room. He melted John's brain.
Yep.
He had a talk that he gave at one of our early networking field day events where he basically said that in a given system, adding people will reduce the fragility of a system to a point. And once you've passed that point, no amount of human interaction will make the system any less fragile and will in fact make it significantly more fragile. So in order to eventually get to a point, like Lexi said, where the system is capable of doing as many things as possible on its own, you literally have to rip everybody out of it because past a certain point, it will start second guessing the system's decisions and cause it to fail. And we need to link that video in this
So-
You
roundtable.
never watch War Games.
Yeah, I don't know, John. Would you like to play a game of thermonuclear war?
I actually think that I think the trust issue is possible and the blame issue is possible, but I actually think it's perhaps a little bit more, I don't know, fundamental even to human nature. I think we're actually at like the Blanchard point of networking. And what I mean is, Thomas Blanchard was an inventor in like 1800 or something. And at that time, people who made firearms made them by hand, right? Every gun stock, every barrel, every piece, like a watchmaker, like they were all like master craftsmen and they filed all these pieces together. And every gun had to have a certain set of pieces that all went together. And you couldn't change the parts from one gun to another because they were different because they were made by a human hand. And Blanchard got brought in to like build a lathe that could make the barrel. And he did it. And then the guy who hired him to do it joked and said, "Oh man, I guess next you'll make one that'll, make a gun stock." Because the gun stock actually has a ton of curves and shapes and is a really intricate piece of wood. And Blanchard, of course, went off and built a lathe that could make a gun stock. And this was something that was, deemed impossible forever. And everyone said, "Oh, well, because, everything has to be, done by hand. It has to be done, done by a person." And there's all these people that have spent all these years training themselves to do these things. And that, I think, was more of the fundamental response to it, was the fact that, oh, this is this is totally different. Now this thing that took me 4 years to learn how to do and took me 4 hours to do, a kid can do it in 4 minutes. And that's hugely disruptive, right? And I really think that in a lot of our cases, we've tied our identity maybe too closely to the CLI and to the things we do day to day versus like the actual intent of what we're trying to do. And I think as an industry, we're at that point, right, where the assembly line is coming. And if you can learn how to use an assembly line to build your network instead of building everything by hand all the time, you're going to be in the driver's seat for the next generation of networking.
So how does visibility solve this problem? Because we've said that
Yeah.
it's all a matter of knowing that the automation system did exactly what it was supposed to do when I asked it to do it every time. How does visibility, and more importantly, how does feeding visibility into the automation system give us the confidence to believe that it worked?
Well, it's all about process here, because the one thing I want to push back on here is this this magical human presence that's going to make sure it's right. Like, yeah, humans are always right. We make mistakes freaking all the time. We're the reason a lot of these networks go down. So what automation allows us to do is to do things consistently and automatically, and therefore what we want to make sure we have a good connection for is the observability solution is designed in a way that we know we have the right parameters so that they trigger the right actions. And that's where the human brain power needs to go in to make sure all these catches and things are in place so that the vast majority of the time, better than a human, it's going to do the right thing at the right time, just like it does on the rockets.
So
automatically.
I'm gonna Tyler, go ahead and add your point here because I was gonna mention something.
So one of my big problems with network visibility / observability right now is that they look at the network. And that's the only thing they look at, and it's kind of a bummer. So if you start feeding that data into a system that's supposed to automatically remediate something, but something higher up the stack causes some issue to occur, and then that data gets fed into this automatic remediation system with no knowledge of the thing that happens above the networking layer where you're collecting this data because you're doing it in a silo, then you start running afoul of introducing change and churn that's not supposed to be there because it's actually not the network. Sometimes it is.
Tyler, you can say DNS. It's allowed. You can say DNS. Well, it's allowed.
Yeah, but that's the point of doing the parameters. Though there's always going to be edge cases, but you got to scope these responses and scriptings for both the builds and the responses to events so that they're contained. I mean, you build guide rails into these systems. I mean, we're already telling people to do these things manually. Why can't we automate them based on the actual data from the network?
I'm going to say, to be absolutely fair to you, you're kind of right. And it's a bit like when you start doing automation with the small tasks, you start off with the changes that are lower risk. You might have standard changes, right, which are pre-approved, and you start automating those because they're lower risk. And that's probably how these kind of systems will start taking their feet is you'll say, okay, you can do these kind of changes, but the bigger stuff, we might hold off for a bit. It's also very true, I will say, on the observability bit, although I kind of agree with Tyler that the scope of them may be a little bit limited. However, these systems' ability to ingest a massive number of different data sources and come out with something useful, I mean, far, far exceeds anything that a human could ever actually do. So, we've got to have some faith in that analysis, which I think is something that's going to be earned over time, right? That's something where you're like, yeah, okay, it really is right 99 out of 100 times, 499 out of 500 times, until you get to the point where you're willing to let it trigger the more complex automation and make bigger decisions for you. And so, and that comes back down, kind of summarizes where we are. It's a trust issue, right? Is you have to have an extreme amount of trust in order to give it full permissions to automate whatever the heck it wants using the other systems. Yeah. And I'm not sure I've seen that in observability systems yet in general, but then again, I also haven't fed it 20 different sources of information to see what it can come up with. So maybe that's just me.
I think that 20 different pieces thing is kind of the problem, right? Like if you've got one vendor who's giving you your layer 3, layer 4, who's giving you your packet loss, you've got a different vendor that is giving you your host metrics. How do you tie those two different pieces? Like who is tying those two different data sets together and then triggering action based on it?
So I have a sort of answer for that. The point I was going to bring up, there's a wonderful movie that I'm sure most everybody in here has watched, unless you're under the age of 30, The Hunt for Red October. Everybody remember that one? It's also a pretty decent book. And there's a scene that doesn't involve the Scottish-Russian sub-captain where they're trying to navigate the submarine through a bunch of underwater canyons. They're in a metal tube going really fast and they don't have a window to look out of. And what are they doing? They have a really accurate map of the canyons and a stopwatch. And they know if I go that way really fast for 3.5 minutes and then make a left-hand turn for 2 minutes and then make another right-hand turn, I'll go through it. And the guy playing the Russian navigator had a brilliant line. He said, if you give me, I can navigate the Swiss Alps with nothing but a stopwatch in a plane with no windows. And the guy right behind him said, yeah, if the map is accurate enough. And that's where we're at right now. And Tyler's kind of alluding to that. We have a system of visibility and observability now that we're building out for the network that gives us the kinds of visibility to build a super accurate map to allow the automation system to operate on just the network. But the storage, cloud, server, security teams all have their own maps, and they're all written in Elvish, and nobody gets to understand them. And the ultimate arbiter of what is the most accurate map needs to be something that explains all of those systems accurately and knows how to ask each of those systems for the right information to return what it could possibly be. And I hope you all got to the answer before I did, because according to my friend Brian Booth, who I had a great chat about this with last week, the answer is AI. We need some kind of a system sitting in between all of those devices that know that if I see this, yeah, John's making a ridiculous face, but if I have a situation where it could be this or it could be that, the AI needs to be smart enough to ask the network if it could be this, do you see these conditions? Ask the DNS servers, do you see this? It could be these conditions. Know that those inputs need to be correlated and fed back to me. As easily as Geordie LaForge asking the enterprise what the intermix ratio is on the antimatter chamber, because it could be an antimatter warp core explosion, or it could be the fact that Barclay's playing around on the holodeck again and using way too much power.
I just think
GPT.
I
didn't say ChatGPT, I said AI.
But here you can't let the perfect be the enemy of the good. There are plenty of things that you can get independently from any one of those 4 different monitoring systems you're talking about. That's enough information to solve small specific problems. You are looking for the keys to the kingdom and the be all end all. That doesn't exist yet. Maybe it'll never exist. You're letting the perfect get in the way of the good.
That's fair, but I have that luxury because I can sit here and tell you what I want my perfect world to look like. And the people who are trying to build that can go, I can't give you perfect today, but I can give you 75% of it if we just do this and this and this. And that's why the companies that provide visibility need to be able to talk to the people that can leverage that for automation. All I've got to do is get them talking.
Well, plus, I mean, you notice on the enterprise, you have this incredibly smart computer, but it still required Geordie to ask the question. The computer didn't go, uh-oh, we're heading towards a warp core breach. Geordie had to go, hey, what is the mixture ratio right now? Is that a problem? You see, even they don't trust the computer to do it automatically.
Hey, they trusted the Android to eject the warp core.
So Geordie was a prompt engineer?
So you're saying even 3 centuries from now, we're still going to be stupid?
Yeah, that's true.
Seems to be the way we're going.
Pretty much.
And relying on the AI to make the decision.
Okay.
And I think your point is really well made, right? The solutions will come along and they will be available to do, I think they'll be suitable to do a certain number of things. And I think the biggest problem is the one that Tom mentioned, which I was going to shout out as well, is basically the guys with boats are going to tell management, and they're going to put in the magazines they put in airplanes that their system is 100% and it's awesome. And then manager's going to tell you, trust it. You should put this in. We should buy this. And not understand why you hesitate and why they can't fire a few more people who currently spend time troubleshooting this stuff to save costs.
All right.
On that note,
Chris, did you have one more thing you wanted to add?
I did have one more thing. So I think there's another way to look at this, which is, one of the reasons why some of the most advanced networks as far as automation goes, well, maybe all of the most advanced automated networks have been built in-house. And one of the reasons for that is in order to build a commercial tool, you've got to play to everyone's weaknesses. and make that all work, right? And so that becomes really, really, really hard, right? A universal automation platform, a universal observability platform even is really, really, really tough. But if you're actually the one building the network and the tools, it becomes a lot easier because you can use your friendly tool standardization and you can build things the same way. And you can actually, standardize the config, standardize what you're doing it. Because, again, to grow back, we're going to go back to the 1800s again. Thomas Blanchard, the way that gunstock thing works is you have to put a model in one side and there's rollers that go over it. And then the knife cuts the wood exactly like the model. And you can't use an example. You can't use a sample. You have to use an actual perfect model. And then you get the same result every single time, right? And that's what we need. And that's where I think observability and automation tie together very, very well, because observability is really just validation. And so if you have a standard intent that you want the network to perform and you know what that is, you know how that is, then you can measure against that and know when it varies from intent and fix it. And it can work perfectly without people involved. But you've got to come from that standardization base.
And I will say that we're actually well down the road of solving these problems because we actually started trying to solve them, kind of like the example that Chris gave with trying to build the gun stock. We are going to have to mess up quite a few of those, and it's going to be ugly and messy, but it's going to be better than nothing. So if we just keep sitting here and hoping that this problem is going to solve itself, you're like my teenager hoping that someone's going to build his Eagle Scout project for him. You're going to have to get in there and get your hands dirty. You're going to have to figure out how these things integrate. And quite honestly, maybe you need to get on a conference call with your visibility vendor and your automation vendor and be like, have you two met? Like, you really should be talking to each other because there's a lot that you could do together to make my life a whole lot less miserable. But by doing the thing, by making it messy and implemented and seeing the problems where they crop up, you're building a better system for the next run. And that is even the dirty little secret of AI. You can't fix it until you break it. And when you break it, the next one gets a little bit better. And then the one after that gets a little bit better. And then 15 generations down the road, it works the way we want it to. But you can't get 15 generations down the road until you have generation 1 and then the next generation.